Hey, it's Random Code here, and today I want to talk about binary search and showcase an implementation in Python. But quickly, binary search is a searching algorithm that helps us find whether or not a number is inside a sorted list, and then get the index of this number as a return value if it is. And just a quick demonstration of how binary search works. Let's say we have this sorted list from 0 to 6, and we want to find 2. We then first look at the element in the middle of our list, then ask is 2 smaller or larger than 3 in this case. And because 2 is smaller, we're going to be looking at the parts below our middle point. So in this case 0, 1, 2. And then again, the middle point is going to be 1. Is 2 smaller or larger than 1? It's larger than. Then move our list to be 1 above. So in this case, our list only contains 2. We now ask, is 2 smaller than or equal than 2? It's not, then 2 must be the value. And how it works when we go through Python, we first define some beginning values, the beginning of our list, int value, the end of our list, which is length of our list -1, the middle point, which we're going to be set later on. We then check while the beginning of our search area is smaller than or equal to our end. We keep searching, and it will always be the case if the value exists. However, if the value does not exist inside our list, at some point we're going to be outside. The beginning is going to be larger than our end. We're going to keep looking for something that's not there. Then we're going to jump outside our while loop and return -1. So if the value is not inside our sorted list, we're just going to return -1. And how we actually do this searching, that we first define our middle value by doing beginning plus end divided by 2. Then we cast it to an int because we don't want any float numbers. Or in Python, instead of casting to an int, we could also just do it like this. That would work the exact same. And we then simply check if our middle number is smaller than target. If it is, change the beginning to be mid +1. If our middle point is larger than our target, take our end point and move it to be middle -1. And then we just keep doing this for a few ticks. So let's actually just run through the code step by step and see how it actually works. So let's say we have our list, our 2 again. We're then going to be looking for 2. So first we find our middle point, which is going to be 3. We then ask, is 3 smaller than 2? It is not. Keep going. Is 3 larger than 2? It is. We then have our endpoint going from being index 6 to be our middle point, -1. So it's going to be the 2 values. Now we're going to be looking at this area again. We then again redefine our middle value to be beginning plus end divided by 2. Find the whole number. It's going to be 1. It's 1 smaller than our target. It is. So move our middle point or our beginning to be middle +1. So again, we're going to end up having our middle point be 2. It's not smaller than, it's not larger than, but it is equal to. So in this case, we return, if we run the code, that our output is 2 because our value 2 is inside the second index position. But if we do something like 7, for example, we're not going to find the value and we're going to return -1 because it's not inside the list, because we're going to keep looking for these elements, but at some point we're going to get outside this area of search and we're going to just return -1. So this was just my quick demonstration of binary search and a walkthrough of how it works. If you enjoyed this quick demonstration, please leave a like and subscribe, and I wish you all a wonderful day.